how do I know my input parameters for calculating streams and ponds?
Alrighty, so for that one, cell size, it comes at a little bit of a trade-off. Let's see here, actually I might steal the graphic from our help files for it. So the software is, the vast majority of our software considers the surface as a triangular, irregular network, so a tin. The hydrology tools consider it as a raster. So each, it creates a series of cells, square cells, and they have a dimension. So the smaller the cell size, the more detailed what you're considering. The larger the cell size, the more information is not being considered. But there's a trade-off there where if you go too small, it takes longer to calculate. So you can make the problem quite gnarly. I think by far, and our default is set to 1 meter, which is pretty consistent for this type of stuff, but you have the functionality to change that. And with that in mind, if you're using like a 10 meter DEM for your top surface, there's no benefit in using a 1 meter grid size. You're not going to add more useful information to that problem by cranking that down. The other parameters, so I talked about the depression fill depth in terms of the watershed functionality. That is consistent across the all the tools. So this allows the example would be allows a puddle to fill up and not just flow stops at a little minor depression in the ground. Minimum pond area is just a parameter to avoid noise. So that puddle example, if we had a little 1 square meter puddle, and in particular on flat terrain, you probably don't want to see each and every tiny little depression. So we're including a minimum area to weed that out. And then this one here, stream drainage area, is really the most influential thing that's going to control how things work. I'm just going to go to my plan view here, or sorry, the 3D view. With this, my streams are being generated when we have a catchment area triggered that's greater than whatever that number is. So here, 7,500 square meters, and we can see does a pretty good job of tracking where the typical channels are forming. That being said, it's not a universal thing, and you'll be able to just kind of poke around in a file and you tweak the number, and you'll find that, okay, this one, I want my streams to extend further up the watershed. So maybe I expect that to go up here or something like that. Well, in that case, I'd lower my drainage area. Or if it's a case, actually I kind of suspect I might be a little generous here, where I am, streams are going too far up the watershed, we can increase it. So let's go with that. And we'll just kind of keep note of where that starts. So there, instead of starting here, we're starting a little lower. So you can play with the number, find what works well locally, and usually there's a consistent number for a particular area. So hopefully that answers the question. The other things that we have, drainage area, minimum area, is just going to amalgamate things. So you have your polygons greater than that number. So that's more so if you're using the drainage area to a linear feature and you don't want a bunch of little slivers going up the hill. Minimum drain radius here would be, if I wanted to run a drainage calculation to this point, but I didn't put my point in the right location, maybe I set it over here. Actually, let's go with So if I ran my drainage area to a point and I had that set as 0, well, it's probably going to delineate a drainage area that goes kind of straight up here and not catch what I intend to catch. So the drainage drain radius is just a tolerance. So in this case, it would go 10 meters, take the lowest point for that 10 meters and work up from there. Just makes it so you don't have to be as exact. I think that's it for the parameters in there.